Hello students, in this particular video I am going to explain to you about a general topic which is called homolytic fission and heterolytic fission. Now the word fission means breaking. So what we are breaking? We are breaking the bonds in between the molecules, because whenever a chemical reaction takes place, then certain bonds must be broken and then certain new bonds should be formed. But how exactly does this breaking take place, that we are going to consider? So there is a covalent bond between A and B. The A and B are the two atoms. Now, as you know that the covalent bond is formed by sharing of an electron pair between A and B, which I have shown by two dots, or you may show even a dot and a cross. Both are valid. Now we have to consider that this bond is getting broken, right? So this bond is getting broken, and therefore uh, we have shown that this bond is getting broken. So this is the electron pair which was forming this covalent bond. Now there are three different ways in which the bond can break. You can easily understand that the electron pair gets distributed equally. So A gets one electron, B gets one electron, and now they are separate from one another. They are no longer having a bond. So we have put a plus sign. Now the other way is that there is an unequal distribution of electrons, such that A has received both the electrons and B has not got any electrons, so unequal distribution. The atom which gets the pair gets a negative charge, and the atom which loses its electron gets a positive charge. Similarly, the reverse thing happens over here. So we in the heterolytic fission, unequal distribution, we'll get negative and positively charged ions, whereas in homolytic fission we will get free radicals. Now a doubt can come in your mind that when there are two electrons, why not there is a -2 charge, but why there is a -1 charge? The answer of that is that if you consider this electron pair, then in fact A has received only one electron. One electron was its own, so there is only a gain of one electron, so one negative charge. Similarly, B has lost one electron, and therefore it has a single positive charge. So in that way you can understand that why A is not having any charge, because that is its own electron. It's not lost or gained. So in this way we can understand that how does homolytic and heterolytic fission takes place during the reaction mechanisms. And now, since in organic chemistry we are always dealing with carbon compounds, so there is a carbon-carbon covalent bond. Now once again applying the same logic, this covalent bond can break in three different ways. Either the electron pair can be distributed equally between the two carbon atoms, forming free radicals, or the electron pair can go to X, right? X is more electronegative because it has more power to attract the electron pair. So it takes away, this curly arrow means that it takes away the electron pair. So you get like this, X negative and carbon positive. When carbon is positively charged, it's called carbocation. The reverse can happen, and the electron pair can move to carbon if carbon is more electronegative than Y, and then carbon gets an electron pair and a negative charge. When carbon has a negative charge, it's called a carbanion, and the Y is not so important for us because we are doing organic chemistry. So you will have to come across a number of times through these carbocations, carbanions, and the free radicals in your study of organic chemistry. Thanks for watching. Hope you liked the video. Please comment.